Okay, let's continue. This video will cover the last 10 question. I think it is from 11 to 20. So question 11 is again on heat transfer. I think it is a very classic question. So the first thing you need to know is that when heat travel from a hot place to a cold place, so for example, hot place in physics basically is another word of saying from a region of high temperature to a cold place, which is a place with low temperature. There are three ways. Either the molecule can vibrate and transfer the energy from the hot place to the cold place one by one. This is called your conduction. Right? Or another way is for this particular hot object, the air or the medium, usually we call this the fluid. So usually this medium around usually around this hot object there would be things that can move. So this kind of things is called fluid. It can be for example air, for example water. So when this fluid get heated up by the hot object, what it does is that it expands, and as a result the density will become lower and this hot fluid can actually rise. Now when this hot fluid rise, it will bring with them thermal energy. So if now I have another object on top, this particular object will receive the heat from the hot object, okay, through convection. So this thing over here is what we call convection. So convection heat transfer is not always that there must be a circulation, there must be convection current. As long as the hot fluid can reach the other object, we can say that your thermal energy is now being transferred by convection. Then the other way is that this hot object will also give out radiation in all directions. So this radiation that is being given out by a hot object, it cannot be stopped. It can slow down, but it cannot be stopped. So if now you go and put your cold object at the bottom, it will still receive the radiation. Okay, so this is the third option, radiation. So now if you are given this context, you have two body, the marshmallow, okay, we call this object A, and of course the heat source, which is your object B. So they are asking you how the thermal energy travel from, in this case B is hot, right, travel from B to A, which is the cooler marshmallow. So since the marshmallow is on top of the fire, we can say that the thermal energy can reach the marshmallow through convection, right? Because your hot air rises, and as the hot air rises and reaches the marshmallow, the thermal energy will get transferred from B to A. Now if you look at figure Q, now the marshmallow, okay, is actually on the side. So this cooler object A, which is the marshmallow, compared to this hot object, the fire B, the hot air will continue to rise. It won't stop because that is how nature is. But can this hot air reach my cold marshmallow at A? Cannot, right? So as a result, convection will not be able to transfer the thermal energy from the fire to the marshmallow. How about conduction? Well, we all know that your air is actually a very poor conductor. So because of that, conduction is also going to be very slow. B to A through conduction is going to be extremely slow, right? So this means that it only left with one last method, which is your radiation that radiate your thermal energy in all direction. Okay, so because of that, Q will be by radiation and P will be by convection. Okay, question 12 is about a refrigerator. So how is a refrigerator different from a fire? Well, a fire you have what we call a heat source. But in a refrigerator, are you going to find a heat source? Is there like a fire in your refrigerator? No, right? But instead, this is the start, right? This is the start of everything because your ice box will absorb heat. Okay, so what happened is that it all starts from here. It will actually turn the air around it cold, and as the air around it cold, it will start to sink, right? And when cold air start to sink, it will actually push up the warmer air at the bottom, and in this case you will have your circulation. So let's look at this. What happened to the density of the cooler air? So it will shrink and the density will actually rise, and when the density is high, it will actually sink to the bottom. Okay, now you have question 13. You have this thing called a double glazed window. So this double glazed window, right, if you study your textbook, is made up of, normally a window is just a layer of glass, right? So for example, this is your glass. What does a double glazed window mean? Well, it means that the window frame actually consists of two pieces of glass, and then they will build their window frame around here, right? So this entire thing is being cordoned off. So let me get an eraser. So this part here is actually inside the wall. Yeah, so this part here is like that. So this is the wall, and of course down here as well. So what happened is that this glass, these two blue thing is the glass, and what is in between this glass is sometimes a layer of air. If you can also vacuum out the air, you can also take out the air. So what you need to know also in this case, this double glazed glass, very expensive one, is actually a vacuum. So it's not even a layer of air, but it's actually a vacuum. That means they suck out all the air already. It's basically a layer of nothingness. So down here they're asking you, how would the thermal energy get through this thing, right, to the other side? Let's say this is hot, the outside is hot, and want to get into your room, which is on aircon, so it is cold, right? So how you get in? Well, can it go through by conduction? Well, we just learned, right, that conduction, right, will need to have a medium, right? Need to have some particles for it to vibrate and all that. But since there is this layer of vacuum here, you would know that your conduction cannot happen, right? Now this layer of vacuum, it also means that there is no fluid in between, right? There's nothing in between them. So there's no hot air to rise, there's no cold air to sink. So as a result, convection cannot happen. So like I said earlier, the only way for heat to get through vacuum is by radiation. So because of that, your answer is A. Okay. Now for your question 14, which of the statement describes what happened to the molecules in a liquid when it is freezing? So when it is freezing, you should know that it is changing from liquid to solid. So in total, there are actually 4 or even 4.5 of this kind of processes. So since we are doing revision, let's recap. So there is from gas to liquid, and from liquid to solid, and then of course we also have from solid to liquid, and from liquid to gas. So from gas to liquid, we have a process, right? What is the name? Start with C. Condensation. Okay. Liquid to solid, we have covered that. It is called freezing or solidification, the more chim name. How about a solid to liquid? Well, I hope you know this. This is melting. And from liquid to gas, you will have the last process, boiling. So why I say 4.5 process? because there is one more process that can allow you to turn liquid into gas. It is your evaporation. Okay, but evaporation and boiling are actually very different process. So you need to go and study about it. The process is very different. So okay, let's go back to the MCQ. So molecules stop moving. Well, kinetic model of matter says that molecule will always move randomly and continuously unless this one is only possible at 0 Kelvin. What is 0 Kelvin? It means minus 273 degrees Celsius. Now this thing is in your syllabus. If you have forgotten what it is, go and revise. Basically, Kelvin is a unit, in fact the SI unit for temperature. Okay. Next, B, molecule decrease in size. Unfortunately, you can't. Molecule is made up of protons and electron, neutron, and things like that. If it decreases in size, that means you must destroy some of them. So cannot. Molecule move closer to one another. Well, yeah, I guess so, because in a liquid state, molecules can roll over each other and there's slightly more space. But in solid, then the molecule will be in regular arrangement and there's hardly space. So I think C is a possible answer. In the spirit of the revision, let's go look at a D. So D says that the molecule moves slower. Well, not necessary. For example, if I have 0 degree ice and if I have 0 degree C water, if they are at the same temperature, that means the molecule will be moving at around the same speed. So that's why D is wrong. Okay, let's look at question 15. Which of the following about waves, so now we are into waves, is incorrect? So here it says that a wave transfer energy from one place to another. Definitely, very factual question. Transverse wave, direction of vibration is perpendicular to the direction of wave travel. Yep, correct. A wave is caused by a disturbance. Well, yes, you will need a disturbance to start a wave. Or longitudinal wave, or can travel through vacuum. And longitudinal wave, some of your example is sound. Unfortunately, sound cannot travel through vacuum, right? So as a result, you know that this is wrong. Okay.